Have you ever wondered what actually happens when you type a question into ChatGPT? What technology allowed ChatGPT to reach 1 million users in just 5 days, a world record, while it took other companies several months or years to do the same? In this video, I'm peeling back the curtain to show you exactly how large language models like ChatGPT work. No computer science degree required. You'll understand what's really happening behind that blinking cursor and how you can use transformers, the T in ChatGPT, to change the way you learn, work, and make money. Hi, I'm Mo, co-founder of OwnFoundations. As #1 stock picker and director at a unicorn startup, I came to see that ownership in AI compound wealth for investors and entrepreneurs, while employees must work harder for the same pay or update their resumes. If you take one thing from this video, make it this. Your own AI-powered business and wealth creation isn't optional anymore. It's your life jacket to stay afloat, so you can live the life you want. #OwnFoundations. What is ChatGPT really? GPT stands for Generative Pre-trained Transformer, and ChatGPT is simply a large language model. But what exactly does that mean? At its core, a large language model, or LLM, consists of just two files, a parameters file and some code to run it. The parameters file is essentially a compressed version of the internet. For perspective, if you were to read the amount of text used to train GPT-3 non-stop 24/7, 365, it would take you over 2,600 years, because this includes everything from Wikipedia to GitHub repositories to financial reports. And the newer models have been trained on much, much more. For a model like GPT-4, that parameters file contains hundreds of gigabytes containing hundreds of billions of numbers, each representing a weight or connection in the model. So ChatGPT is a pattern recognition system that predicts what words should come next in a sequence based on statistical patterns observed in a massive dataset scraped from the internet. Point 2. The 3-stage training process. The magic of ChatGPT comes from a 3-stage training process that transforms raw internet data into a helpful assistant. First stage, pre-training. The first stage is about knowledge acquisition. The model downloads and processes a massive chunk of the internet and learns to predict what word comes next in any sequence. During pre-training, the model isn't trying to be helpful or answer questions. It's just learning the statistical patterns of language. If you ask the base model, who is Satoshi Nakamoto and why did he create Bitcoin? It would just continue with whatever text typically follows that phrase online, perhaps listing various theories about Satoshi's identity or quoting passages from the Bitcoin white paper. Training this model requires unbelievable computational power. For models like GPT-4, we are talking supercomputers running non-stop for centuries, if stacked sequentially. Price tag in the billions of dollars. Second stage, Supervised Fine-Tuning, or SFT. Stage 2 transforms this raw pattern matching engine, aka foundation or base model, into a powerful assistant. Companies create datasets of conversations showing exactly how an ideal AI assistant should respond to different questions. Initially, human labelers create these examples following detailed guidelines about being helpful, truthful, and harmless. The model learns to imitate these examples, adopting the persona of a helpful assistant rather than just continuing internet text. Third stage, reinforcement learning, or RL. The final stage is where models really shine. Instead of just imitating human-written responses, the model now practices by generating many different solutions to problems and learning which approaches work best. A key technique used here is called reinforcement learning from human feedback, or RLHF. Here's how it works. The model generates multiple responses to the same prompt. Human evaluators then rank these responses from best to worst based on helpfulness, accuracy, and safety. This feedback trains a separate reward model that scores responses, and then the main model gets updated to maximize these scores. RLHF is what makes ChatGPT genuinely helpful rather than just technically impressive. It's how these models learn to follow instructions, avoid harmful outputs, and provide responses that humans actually prefer, not just what's statistically most likely. You can think of stage 1 as reading a book like The Intelligent Investor by Benjamin Graham. Stage 2 as watching real experts invest, while in stage 3, investing yourself, discovering which methods work best for your portfolio through trial and error. Reinforcement learning produces fascinating results. The models develop their own thinking strategies that involve breaking down problems, trying different approaches, checking their work, and even having aha moments. DeepMind's AlphaGo used reinforcement learning to defeat Lee Sedol, the world champion at Go, a game with more possible positions than atoms in the universe. Its now legendary Move 37 shocked experts who initially dismissed it as a mistake before recognizing its brilliance. It wasn't just a game-winning strategy, it was AI discovering solutions humans had missed for over 3,000 years of play. You can watch the full movie AlphaGo on YouTube for free. I make sure to put the link in the show notes below. Today's thinking or reasoning models like OpenAI's O1 or O3, Google's Gemini and DeepSeek's R1 all show similar emergent abilities, and I'm sure all models will have reasoning capabilities soon. Reasoning takes the model longer to respond, shows their reasoning step by step, frequently checks their own work, and considers multiple approaches before coming up with an answer. When asking math or coding questions, you'll notice thinking models don't just give you an answer. They create a detailed chain of thought that sometimes even includes statements like, "Wait, that's not right," or "Let me recheck this calculation," just like a human would. Pretty amazing stuff the longer I think about it. Point 3. How LLMs work under the hood. Now for the fascinating part. What's actually happening when you ask ChatGPT a question? First, your text gets broken down into tokens, roughly parts of words. For example, the sentence, "What is Bitcoin's halving cycle?" something we talked about in this video here, might become 6 to 7 tokens depending on the tokenizer. These tokens get converted into numbers that represent their position in a multidimensional vector space. Think of it as a giant word map, where related concepts are positioned close to each other, whereas unrelated words are far apart embedded. In this vector space, the classic example are the words king plus woman minus man equals something close to queen, because the model has learned the semantic relationships during training, preserving the royalty aspect while changing the gender. At the heart of LLMs are neural networks, computing systems inspired by the human brain. These networks consist of interconnected neurons that process information in layers, learning patterns from data, such like our brains learn from experience. The real breakthrough came in 2017, when Google published the landmark paper "Attention is All You Need," introducing the transformer architecture. This parallel processing not only creates more powerful models, but dramatically reduces training time. This revolutionary design solved a fundamental problem. Previous neural networks process text sequentially, severely limiting their understanding of text in longer passages. This transformer architecture is what powers ChatGPT and every other major language model today, enabling them to understand context, generate coherent responses, and complex reasoning tasks at unprecedented levels. The model makes predictions by calculating probabilities for every possible next word. It's not just picking the most likely word each time, it introduces some randomness, which is why you get different answers if you ask the same question twice. Point 4. The Swiss cheese problem and tool use. Despite their impressive capabilities, LLMs have what experts call a Swiss cheese problem, areas of inexplicable weakness amid near-genius level strength. For example, several models from OpenAI, the company behind ChatGPT, can solve complex mathematical problems most humans can't, but sometimes fail at simple questions like, is 9.11 greater than 9.9? Try it yourself when you feel down. The most advanced LLMs address these limitations through tool use. Instead of relying solely on their internal knowledge, They can search the web to get up-to-date information or run code to solve math problems. Even though tool use can create powerful synergies by combining the model's language understanding with specialized tools that handle tasks where LLMs traditionally struggle, Bitcoin's core principle applies here too. Don't trust, verify. Because only if you verify, you can truly own the product of your work. Point 5. Where is this going? The pace of advancement in the field is staggering. Since 2018, the release year of GPT-1, we've gone from 170 million parameters to models with trillions of parameters that can see, hear, and generate images as well as videos. This multi-modality represents a major leap in AI capabilities. Just as text can be broken down into tokens, audio, images, and video can all be tokenized in similar ways. When you realize that a video is just a sequence of images and an image is just a grid of pixels with color values, you see how everything can be reduced to numbers for AI to process. This tokenization allows a single model to see, hear, and understand our world in an increasingly human-like way. It won't be long before we have embodied AI, physical robots everywhere around us. That's why projects like Tesla's robot Optimus are so significant. Makes me think of...
My name is Optimus Prime. We are autonomous robotic organisms.
But hang on, what good is understanding LLMs and transformers for my life if the AI does not give me what I actually want? Enters prompting, the power of asking the right questions. If you're interested in making AI actually give you what you want, check out this video here.